So right here we are going to learn about the nth root. So and we have already learned about, and you probably know a lot about the square root of a number. But right now, we don't only have square roots. We have like third root, fourth root, fifth root. I don't know, 60th root, and things like this. So let's get right into it. So if we have the square root, how do you find the square root of a number? Well, you basically look for some number which is so you gotta look for a number which, if we multiply by itself 2 times, we get the number under the square root sign. So something that we usually don't write at the square root is this little number 2, because if we have 36, if we would take the square root of 36, we would get obviously 6. We know that because 36 is a number which has a integer square root. But like the main thing here is that this little 2, you can also say that we are looking for a, and a is the number that's going to be the square root of 36. And we can also write the square root like this, little 2 up there on the top left corner. And we could say that a is a number that if we would raise to the second power, we would get 36. So 8 times a is 36, and therefore a is equal to 6. So this is sort of our logic. So whichever root you take, you gotta look for a number that if it's the square root, you gotta multiply the number by itself 2 times. If it is the third root, you gotta do it 3 times, and then that's always how you could find the number. So we have 125 here, and the third root of 125, let that be the letter b. That means b times b times b, because it is the third root. So you're gonna multiply b 3 times by itself, so b times b times b is going to be equal to 125, and therefore b is going to be equal to 5. So yeah, pretty cool. And that's how you could always do it. So there you have b times c. Now if it's the fourth power of a number, then let the number be c. So then it is c times c times c times c. And what number would you need to have? What number would you need to multiply 4 times by itself to get 81? That is 3. So the number we are looking for here is 3. And so 3 is the fourth root of 81. So I think you can get the logic right now, that second root multiplied by 2 times each other, 2 times by itself, third root 3 times, fourth root 4 times, fifth root 5 times. So if you are looking for the fifth root of a number, you are essentially looking for a number which, if we will multiply 5 times by itself, it would give you 32, the number under the radical sign. So and what's that number going to be? So d times d times d times d times d is going to be equal to 32, and then d is equal to 2. So you kind of get this. You got this idea here. I think you can take a screenshot of this if you would like to, and then let's get into some problems about this topic. So you have something that you right now you have to simplify an expression. 7 times the fifth root of, so we have this, and x raised to the 15th power, and then our job is basically here to simplify this expression. We had exponent, I mean not exponent, but we have identity thirds. That was our topic a little bit before this. And then we learned an identity for square roots, which also works for the fifth root of a number, that we can rewrite this expression like this. And then so this is going to be equal to, as we have covered earlier, this is going to be equal to just 2, because 2 times 2 times 2 times 2 times 2 is 32. This x to the 15th power is going to be the fifth root of x to the 15th power is going to be equal to x to the third power, because if you think about it, this x to the 15th power is just x times x times x times x, and it just, keeps going on, and times x. So 15 times x, and if we would like to, so sort of, if we would like to get mm, the expression which we would have to raise to the fifth power to get x to the 15th power, that is going to be x to the third power, as we have thought about it earlier, because x to the third power raised to the fifth power is equal to x to the 15th power. So that's sort of our explanation here. So that, and then that is 2 times 7, that's 14 times x to the third power. Okay, so this was one of the problems. Also, something interesting, that if we have that we have already covered that under a square root sign there usually couldn't be a negative number, so you don't have like something like this. This is not a valid expression. I mean, to some extent it is, and later it might become valid, but right now for our current studies we don't really deal with the square root of -9. However, if you would like to know something like the third root of -8, that is very much doable, because that's -2, because -2 raised to the third power is -8. So, -2 times -2 is 4, times -2 is -8. But also, you can't really think of a number of which the fourth root is, let's say, I don't know, -16, so, this also doesn't really exist. And basically the explanation here, and we could even check like something with the fifth root of a number. Let's go with let's go with the easiest one, which is -32. We had this a couple of times today, but this is doable, because -2 is the correct answer here, because -2 times -2 is 4, times -2 is -8, times -2 is 16, times -2 is -32. So this is very much doable, and the thing that you would like to, the thing that we would like to sort of point out here is that, I can write that little 2 in there to help, that if it's a even number up here, so if we are taking the something even square root of a number, then it can be a negative number. However, if you take an odd number here in the top right corner, so if you take like the third or the fifth or the seventh root of a number, then this is doable, of a negative number. So under the radical sign, you can always have a negative number, as long as the number in the top left the top left corner is a odd number. So this is another takeaway that is important about the nth root of a number. Okay, next one. We could have something like, oops. So yeah, let's have another problem. Let's say 2 times the square. Oh no, not even square. Let's go with the third root of x to the 6th power, 6 times y raised to the 9th power. And let's throw in, this is also going to be an easy one here, 27. So right now we already know that we could like take the third root of each of these numbers or expressions individually. So we could we could take the third root of 27, then take the third root of x to the 6th, and then take the third root of y to the 9th power. So what we are going to do here is we will have 2 times, so the third root of 27 is going to be 3, because 3 times 3 is 9, and 3 times 9 is 27. then it's going to be x raised to the second power, because x raised to the second power raised to the third, and if you raise this one to the third power, like this, then we would get x to the sixth power. So this is the expression that we would have to multiply 3 times by itself to get x to the sixth power, and with the same explanation is going to be y to the third power, and this is like our final answer is going to be 6 times x raised to the second power times y to the third power. So this is our final answer here.